Hi, everyone. Today, what we're going to work our way through is the volume of prisms and pyramids. And we'll even sneak in a sphere at the end of today's topic. So, what I want to do is I want to spend our time working again with three-dimensional shapes, but this time we're talking about volume. So, you'll see at the very top there, what we're referencing now is the space inside an object, that being a three-dimensional object. So we're going to imagine if we had to fill that object until there was no more space inside. Okay, so you take a look at problem one. We have to go through and determine the volume of that shape. Now, I'm going to go through problem one with you because I think everybody should be able to get through problem one, primarily because I think that's like the one three-dimensional formula that most people tend to remember. So I'm just going to make that a little bigger for us to work through. I would expect a lot of people to remember how to calculate the volume of that rectangular prism, or we just call it a box, as length times width times height. And so we can now have our 10 by our 8 by our 12. And yeah, we're probably pushing buttons on that. Or maybe we go 8 times 12 is 96, and then to multiply by 10 means put a 0 on the end. So 960. And now that we're talking about volume, we're talking about three-dimensional units. There is your centimeters cubed. And there we go. Pretty straightforward, hopefully pretty direct. Not too bad. So I'm just going to shrink that down a little bit, and we're going to slide that sideways to now be able to talk about problem B. Okay, this is where we're going to start to stray now, and my guess would be an awful lot of us would struggle a lot more on B than A, primarily because we don't always feel like we understand the formula to that shape. However, I want to come to something that we're going to formally get down a little bit later. But it's the idea for us that when we go to find the space inside of an object, really what we're doing is we are calculating the area of the base and we are then multiplying that by the height of an object. That is true every time we are calculating the volume of a prism. Now, a lot of us don't always understand what the definition of a prism is, and I'm going to kind of simplify it down a little bit. In fact, I'm going to tweak it a little bit. And it's any shape where the top shape is exactly the same as the bottom shape, where all of your sides have straight edges. So, a lot of us don't necessarily understand that there's actually a shortcut formula for all your volumes of your prisms. Your volume is the area of the base times the height. And as I said, we're going to get this down in very formal terms in a bit. But that gives us something to try to work our way through in B. See, if we didn't see that the volume was area of the base times the height, take a look back into problem A. What shape is on the bottom of that? It's a rectangle. How do you calculate the area of a rectangle? Length times width. And so really that formula is the area of the base times the height. And you see that. There is the area of your base multiplied by your height. So I'm just going to get rid of that green formula, if you want to call it that way, on the bottom. And instead, what we're going to work our way on is that problem in B. Because I'd like us just to note that right now, if I was to look at the shape that was the base of that back shape, my base would be a rectangle. However, the problem is my top shape isn't a shape at all, it's an edge. And so because of that, we may look at that shape in B and we may go, oh, it's not a prism. And so I need a formula for that when we really don't. Because if we were to take this shape and flip it up onto its end, then could we maybe see the shape in this form, where now the area of my base is the same as the area on the top. Now, if we come up with like our less formal names for these, I've already used the term for the first one. Like we call that an awful lot of just a box, but that's formally a rectangular shaped prism. Question B, you can now see maybe why that's a triangular based prism. We just happen to refer to it as a tent. Now, the diagram as it was originally given to you in B probably looks like a tent. The one that I've changed so we can view it as a prism probably looks more like a, I don't know, like a piece of cheese, maybe like a slice of cake, maybe something like that. But if we look at that blue and red diagram, we can maybe see how to go through and calculate the volume of that prism. To calculate my volume, then that means I need the area of the base, and I have to multiply that by the height. So when we look at that portion that's circled in purple, we need the area of the rectangle. So I'm just going to shade that in on our original diagram. We need to calculate the area of that rectangle. And to calculate the area, I need base times height divided by 2. So my base was 15, my height was 9, divided by 2. Now what I need to do is I need to multiply that by the heights of my tent. Now it's kind of weird at times because we may mistake this 9 for the height of our tent because we would call that like the height. And especially when you look at it, if you were to ask somebody, hey, how tall is your tent? You'd probably say 9 meters. But when we take a look at the blue diagram on the side, we'll notice that really what we're talking about is this dimension that I'm highlighting in purple. And if we notice that really what that implies is this dimension that I'm now highlighting in purple. Really, it's like how deep is the tent? And so maybe then we can recognize that there's your 20. Okay, I'm going to get rid of that red for a second because I do want to maybe show us just a formula to it. That there will be some people who really want to be formula based, and what they might do, is to go through and say, well, I need my base times height divided by 2 because that's my triangle. And now you see just as much why the H's get confusing. Like, well, which one of those H's are you talking about in blue? And we recognize now that we've gone through the problem that those H's mean two different things. This H that I've circled in red is the height of the triangle. This H that I've circled in purple is the purple length. And so, as people work through this formula, you'll quite often not even see this H on the end. And you'll see it either referred to as a D for the depth of the shape, or sometimes you'll just even see it written as an L for length. So, if you want to be like a little more formula-based, you'll often see something like that in blue, of which, since it's all multiply and divide in that case, sometimes you'll even see it written that way. Now, we're okay with it because we walked through it in its parts earlier on, that we get that it's going to be the base of the triangle times the height of the triangle divided by 2, then multiply it by the depth of the tent. Okay, we get to that point, and I'm okay if you want to push buttons on that case. Like, those are relatively large numbers. So for us to go through and calculate our 15 times our 9 divided by 2, multiply that by 20, that's going to get us 1,350. We just need to make sure that we put on our units There's our meters cubed, and we are good. So we've walked through a rectangular-based pyramid, or prism, a triangular-based prism. Now it's time for us to jump a little bit. So earlier where I had said that we are going to formally get down that relationship, this is where I'd like to get it down. I'd like us to formally write on our page that the volume of a prism is equal to the area of the base times our height. And now what I'd like you to do is I'd like you to take a look at the shape I gave you in C. Now, here's where definitions come into play a little bit. And technically, what you see in problem C is not a prism. Because technically, a prism dictates that all of your sides have to be straight. However, if we're going through to calculate the volume of that shape, we can treat that as if it is a prism. You take a look at what shape would be on the bottom. And notice that that shape that we would have on the bottom would be the exact same shape as what we have on top. Okay, what shape are we dealing with in this case? We are working with a cylinder. But if I was to kind of cheat the definition a little bit, I could call a cylinder a circular-based prism. Okay, well, how do we calculate the volume of any prism? Well, the volume of any prism is the area of the base. Well, that base is a circle. And we all know how to calculate the area of a circle. It's pi r squared. And now we need to multiply that by height. So I'm going to multiply it by height. I didn't see the multiplication symbol in there, so I know that that means multiply. And there's our formula, if you want to think about it, on how we calculate the volume of a cylinder. Area of the base times the height. Now the rest is just us plugging in numbers. So we have our pi. We're not going to fall into that trap. 12 is all the way across that circle. We need halfway, so we've got 6. And the height of our cylinder is 8. The only thing we have to be careful of here is we need to make sure that we follow bed mass. So maybe as a little reminder right off the bat, we jot that down, but we can skip that line. That what that works out to be is 288 pi. Now, as we discussed earlier, you can leave that in that form as long as we put on our units. Or because we don't talk about it that way, we could change that into an approximate after we found the 288. And we're going to get 904.78 centimeters cubed. And there we go. So I'm going to argue to you, the more that we can use our cylinders, our prisms, as area of the base times the height, then the less beholden you are to having to memorize formulas. We should already know our two-dimensional formulas off by heart. And so this is how we start to build into 3D shapes where we don't really have to memorize too much. Okay, let's jump into the next problem. What we see in D now is a different shape. So we recognize that that is not a prism because the shape on the bottom is a rectangle and my shape on top is a point. It's a vertex. So clearly not the same shape. However, there is a key property to this, and this would be called a pyramid. And in fact, we actually call our shapes all based on their base the same way we did when we dealt with surface area. This would be a rectangular based. And since it comes to a point on top, pyramid. Okay, I'm going to just get rid of that red label down below because I also want us to make sure that we understand on that diagram. I know it's not very clear, like it's not labeled very well, that 12 meters applies to that height of the pyramid. Okay, there is another key property for us to recognize, that when we work our way through, the volume of any pyramid is going to be 1/3 the volume of the prism. And maybe in your past, you had a teacher that went through and did a little experiment in grade 7 or grade 8 where we filled up a pyramid and then we would dump it into the prism, and then we fill up the pyramid and dump it in, and maybe that was sand, maybe it was water. But you found that it always took 3 pyramids to get you up to the prism. And so therefore, each pyramid is 1/3 the size of the prism. Now, if we can remember that green property, then you never have to memorize your formulas. Because we could look at that and we could say, okay, I know then that the volume of that pyramid has to be 1/3 of, so now my multiply. Well, what if that was a prism? Well, that prism would now be a rectangular-based prism. And how do I calculate the volume of a rectangle? How do I calculate the volume of a box? Length times width times height. And if you were to look on formal formulas for that, they're just going to simplify the fraction and multiply them. And you'll see that as length times width times height divided by 3. Now, I like keeping the 1/3 out in front. That's just to get comfortable with it, because depending on how long you go with this, you might really want that 1/3 out in front for what you end up dealing with in grade 12. You're going to see me keep using that 1/3 because we know our fraction operations and we should be pretty comfortable with it. Okay, I'm going to plug in my values. I know that my volume is 1/3 the length by the width by the height. And there we go. So we can go through and we can push some buttons on it. And so we've got our 7 times our 6 times our 12. Now we have to take 1/3 of that, so we're going to divide that by 3, and we come in on 168. Only thing left to remember, put on your units, and we are good. Okay, hopefully not too bad, but that now allows us to get down a very formal property about pyramids. So what you see at the top of your screen, the volume of a pyramid, I'd like us to get in that is 1/3 the volume of the prism. And of course, it's like the matching prism, so the same based prism. Okay, I want to leave you with E. I want you to be able to work your way through E. So given everything that we've talked about today, I think you guys could go through and come up with the volume of this cone, even though we've never even talked about a cone today. Okay, so I want you to come up with a solution for the volume of that shape. Pause the video now. Okay, we're back. So if we were to start off, and maybe we're going formula, we know that our volume is 1/3 the volume of the prism. So what would that prism be? Well, it would be a circular-based prism. And I know that the volume of a prism is the area of the base times the height. So that red shape, that red base, is a circle. So the area of a circle is pi r squared. And now I need to multiply that by the height. So what we see then is 1/3, and what I just circled in green, or boxed in green, there's your formula for the volume of the cylinder, what it would have been had it been a prism. So we've got that blue, and now we were able to just sub in our values. So we've got our 1/3 pi. We see that our radius is 5, and our height is 9. And so we can go through and we can calculate that. Some people like to put this line in, and they like to calculate the 1, and I'm just going to highlight this a little bit, the 1 times the pi times the 5 squared times the 9. And so they like to put together everything that they would get if they multiplied straight across the top. So we still have to follow BEDMAS with it. And so when we have our 5 squared, there's our 25, multiply that by 9, there's 225. On top, I've got my 225 pi, and then on the bottom, I've got my 3. Now, I will also have a bunch of people that will do the divide by 3 at the same time, and they may jump straight to 75 pi. So if we come in on that, then I think we're doing great. If that's your final answer, then put on your units. If you wanted to go one step further to make sure that we now have a better understanding, then there's your 235.62 meters cubed. So that takes us now through a full review of all of our prisms and pyramids, and maybe we have a little bit of a better understanding on all those topics from what we had in the past. We got a chance to see them again, and maybe we got a chance to look at them a little differently. Okay, what I want to do is I want to spend some time doing with one other shape. And I told you at the very beginning we were going to sneak this one in. We're going to sneak it in now. So that's the best I can do to draw a picture of a sphere and try to make it three-dimensional. You're going to have to draw some spheres from time to time, and I just try to draw what looks like curvature around the middle. This is not going to be on your handout. This is us going through something really quickly. You may be doing this on a separate piece of paper or on the back of that, or maybe even sliding that into a little bit of a space on that handout. What we're going to do is we're going to go through and we're going to deal with the volume of that sphere. Now, as much as I've spent today, last time talking to you guys about we don't need formulas for all this stuff, I think when it gets to the volume of a sphere, we're probably going to have to memorize a formula. So let's get that formula down. For us to calculate, I think your best version is this: 4/3 pi r cubed. However, for everything that we've seen before, you may see everything multiplied together on top and then the divide by 3. I don't care what version you use. However, if you were sitting in a grade 12 class, you're going to really like the blue version better. I'm going to use the blue version. If you're really stuck on the green version, then we should match up in the end. So for us to go through and calculate that volume, then I see on that diagram that I have a diameter of 12. That's going to give me a radius of 6. Now, I doubt that we know what 6 cubed is off the top of our head, so we're going to calculate that to get our 216. Some people like to write this line in just because they may make a mistake with some of their keying sequence, but I never have to see that gold line. If we can take the 6 cubed, calculate it to 216, multiply that by the 4, then some people are going to like to put in, and I'm just going to change that color, this line of 864 pi divided by 3. But just like the previous example, I'm going to have a bunch of people that if they can divide out that 3 evenly, they're going to do it all in one go and come straight down to 288 pi units. Now, as we said before, if that's your final answer, then put on your units. If not, then make sure that we include them when we get our decimal approximate, and we should be coming in on 904.78 centimeters cubed. Okay, I think probably that sphere would be one of those shapes where we have to kind of memorize a formula for that. But every other shape, we should be able to build it through two-dimensional shapes. And those 2D shapes, we should have had enough practice by now that we're pretty good at working with those formulas. Okay, your job now, jump in and get some practice going through and dealing with volume of prisms, pyramids. We're going to save the practice on the sphere till next time. Okay, good luck.